Lists are more or less the most used data type for storing and processing a group of data. If you look at a lot of example problems or sample tasks, most of them predominantly use lists to solve them. Lists are used to denote a sequence of data. The following features identify a list. So lists are denoted by square brackets. Any data that is declared within the square brackets is considered as a list. So this is how we declare a sample list. Give a variable and you assign a value and you provide these values within a square bracket. So this means that we have three elements. We call each of these entities as items or elements, and together these three elements form the list L. So list L contains elements 1, 2 and 3. That is how we used to say it. But do not confuse this square bracket we use for indexing. Both are different. Okay, in indexing we use a square bracket on the variable itself. On a collection like this, we denote the index inside the brackets for the variable directly. But in lists, we declare the values for the variables inside the square brackets. So this is the difference. Even though they both use square brackets, their meanings are different. In a list, let me repeat it again. In a list, we use the square brackets to provide values and assign it to a variable. But in indexing, we use these brackets directly on the variable itself. So next feature is that repetitions are allowed in a list. So we can have duplicate values in a list. It is not an issue. If I run it, as you can see, it ran successfully without any errors or something like that, even though we have multiple copies of the same number here. A list can contain any data type as its element. So this is an important feature of list that extend or expands the usability of lists. So in case you are familiar with other programming languages, you may have used arrays. Arrays are an indexed collection of the same data type. You can only have integers in an integer array, only characters in a character array. So this lets us use functions and operations specific to that particular data type in an array. However, in a list, we can have a combination of multiple data types. So this lets us process the data more efficiently without having to do separate processes for each and every data type within the particular collection. So in Python, we do not have arrays as the default data type. You can have external libraries that use arrays, but by default we do not have arrays in Python. So instead of that, we have lists, but the difference is that in arrays you can only store one particular data type, but list can have multiple data types within it. So here you can see we have integers, we have single character, and we even have combination of characters or a string. So this is permitted. And in the next case, you can see it even has a float and also a list within it. So you can have a list inside another list. As we said, list can contain any data type. That means it can even contain lists or other collections like dictionaries, sets or tuples. So you can think of a list like this. It is a sequence of data arranged one by one. So now consider this list. We have three elements, so 1, 2 and 3. So this representation is nothing but the same as here, where you have three different elements. Now look on the next one. For this list, you see we have 1, 2, 3, and then here we have three elements, and then here we have a string and a float. So we have three integers, a list, a string and a float. So this means that it contains only 6 elements, that is 3 integers, 1 list, 1 string and 1 float. So even though the list within this L2 contains 3 elements by itself, that doesn't mean we have totally 8 elements. So for this list, this entire section or this entire list is considered as one particular item. So you distinguish or separate the elements using your commas. So you can see we have 1, 2, 3 and this is 4 because this entire thing is one item. So you have a comma here and the next comma follows over here, then you have another one here. So totally we have 6 elements in L2. Next, in a list the order is maintained, that is, it does not change. So every element is going to remain in the same position. So we can use indexing and slicing operations in a list. So consider this example. So we have L equal to, within the list we have the values 1, 2 and 3, and then this is a single item. As you can see, this 4 and 5 together is grouped as one, that is a single item, and then we have another string Python. So totally we have 1, 2, 3, 4 and 5 elements within L. And as always, indexing in Python starts from 0. We have each item at one index each. And similarly, negative indexing starts from -1 to the starts from -1 from the last to the start of the string. So here is an example value, example list with values. The indexing starts at 0. So we can find the element in the corresponding index using this notation, just like in strings. So remember that strings are a collection of characters. So we have indexed each character in a string. Likewise, list is also a collection, and we index every element in list from the first element to the last. So L of 2, it gives the value of the second index or the third position. So here is 0 and then this is 1 and this is 2, right? So the element at the third position is the second index, which is 3. And here, what about L of 4? So L of 4 gives the value at the fourth index or at the fifth position, which is your string hello. Now this value itself is a collection, right? Because strings are a collection of characters. Hence you can further index it or slice it. So in the next case, if you look at this L of 4 is nothing but your hello, right? So this is basically your hello, and in this string you are again indexing, so which will give you the value at the third character, value at the third index of this particular string, which is your L. So this is the same as giving a representation like this. You can slice it, slice as it is a string, and in the next example, you see we can also perform slicing. Again, as with the previous case, this L of 4 stands for this hello, and this is also a string, so you can slice it like we saw in the previous string examples. So in the next example, we have a list inside another list. So as I mentioned before, even though this internal list contains many elements, as far as this whole variable is concerned, this is just one single item for this variable, right? So if I ask how many items or elements are in this list, your answer should be 1, 2, 3, and this entire thing is the fourth element, and this entire string is the fifth element, and this is the sixth element. So the total number of elements in this L2 is 6. And L2 of 3 returns the value at the third index. So what about L2 of 3? And again you use indexing on that, right? Same as in the previous case, this L2 of 3, let me run this cell. Now L2 is stored in my memory. Now L2 of 3 is this particular list, right? Now within the list I am indexing again, so this will give me the value at the first index. So this is 0th index, this is the first index, so my output value is going to be 2. So as long as your output is a collection, you can keep indexing it until you can no longer do it. So if we are able to index it, we can also slice. So lists too can be sliced, and the rules are the same as that of strings. So this is the syntax for slicing lists. You give the starting and ending index you want to extract, along with how many items to travel at each step. So the slicing starts from the start index, it goes till the end index excluding it. Again, always make sure the end index is exclusive. So you don't exactly include it, you just consider up to this point, which is until the previous element of the end index. And steps are used to take every nth item of the list. So if you give the steps as 2, you consider every second character on a sequence, and then skipping start will default to 0, skipping end will default to length of the list, that is the complete list, and then negative index reverses the direction. So as you can see, the rules of slicing are same as that of the string. So again, let me tell you, learning Python is progressive. Every concept you learn at one topic is used at the next topic. So until and unless you are clear with the previous topic, do not move over to the next one. It will only make things more complicated because your basics are a bit unstable. So since we have covered about indexing and slicing in detail while teaching about strings, I want you to answer these yourselves along with me side by side as I explain solving them. So here we have a list which contains 9 elements. It's 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the 9 elements within the list L. So what will be the output over here? We start at 4, the ending is 8 and number of steps is 1. So when the number of steps is 1, you just go through it consecutively or continuously, and you start at 4, the starting index is 4. So this is 0, 1, 2, 3 and 4. So it starts from here, goes till 8. So 5, 6, 7 and 8. However, we exclude the last index, which means it will stop over here. So this alone is going to be your output. And next we have A equal to L of, you start at 2 and you don't mention anything here, which will default to the end of the string, or sorry, end of the list. And again, we don't mention any steps, so it will just take characters one by one. This will print everything from the second index, that is, it will start from here and print everything, right? So I'm not printing it out, I'm just storing it in a variable A. Now if I check the value of A, we can find the output. Next we have L of 3, which will just give you the element at the third index, which is number 4, and then 3 is to 4. So what do you think will be the output over here? You start at 3, you go till 4 but exclude it, which means you stop at 3 itself. So you start at 3 and end at 3. So your output is just going to be that particular one element. Now note here, you need to remember one thing. So when using indexing, you get a value as the output, but when you use slicing, you get a list as the output. As you can see, this is just your plain number, which is your value, but here the output is a list itself. So slicing a list always returns a list. You need to remember that very well. Next again, so we have 0 to 4, which will give you the elements from the starting until the 4th index. So it is 0, 1, 2 and 3.
Quiz time guys, you got a few minutes to think.
So here are two simple questions. You have a list with the following value. So I want you to tell me what is the output of doing this particular slicing. And the next question, input a random list and extract only the last 5 elements of the list. You can finish it in 1 or 2 minutes. So just try it out, and in case you are not able to get the output or you are having difficulty in doing it, just kindly go back to your string indexing and learn it thoroughly, and then come back and try again, because indexing and slicing are concepts that will stick throughout your collections. So they are not just applicable in your strings and lists, they are even applicable in other data types. So you need to be very clear about how indexing is done and how slicing works. So if you are having doubts or still confused about it, go back to your string indexing and slicing video, check the examples, try them and practice more and get it cleared. Only then you will be able to perform indexing and slicing in other tasks, because the rules of those two are going to be the same for any data type. So you need to be clear about them. What does it actually mean? You are instructing your program to slice this particular list, where you start at index 3 and end at index 3, but you skip at 2, you take every second character, right? So take this list, it has totally 9 elements. So indexing starts at 0, so this is 0, 1, 2 and 3. So this is your start index. So you start from 3 and end at 3 itself. So note that the ending index is always excluding it, right? So which means your program has to stop at index 2. So you are asking your program to start at 4 and end at 2. But note here, you are also asking it to skip or take every second character. So how is it possible? You start from here and end over here, but you take every second character. And also note, we are not using a negative sign here. So if you had used a negative sign, which means you are traversing from backwards or in reverse direction, but you are using a positive sign, which indicates that you are moving from left to right. So do you think about these scenarios? So we have 3 scenarios. One is you are asking the program to start at the 4th index, other you are asking it to end at the 3rd index, and you also ask it to take every second character, but still you want it to move from left to right. So it is not possible, right? It is too conflicting, because you can't ask it to go in the positive as well as negative direction at the same time. Hence the program is not able to get an input for this, to get an output for this, and hence it will give you an empty string. So empty string is a list with no values. So you cannot slice this particular list, so it gives you an empty list as the output. So this is the result of the first question. Next, input a random list and extract only the last 5 elements. So let me take the same list as my input. Fine. So how do you extract the last 5 characters? You can do it in multiple ways. So the first way is that if you know exactly what is the value, and if you know exactly how many indexes or what is the length of this, you can do it easily. So first find the length of L. As I said, length function can be applied to any collection. So if you give length of L, you get 9, which means you know that there are 9 elements. So indexing will be from 0 to 8. So now that you know what the indexes are, you can extract the last 5 elements easily. So it is going to be from the 4th index. Since it is 0 to 8, so if you start at 4, you have 4, 5, 6, 7 and 8. So you have 5 indexes, you will get your output. That is if you know exactly how many indexes are. But if you don't know how many elements are present in the list, you can always go for the generic notation. So that is, you can just give it directly length of, you have to give a start index, end index and steps. So start index, you are expecting the last 5 elements, right? So it will be, you can solve it step by step. So L of, first you give length of L. So this will give you how many elements are there. Since indexing starts from 0, we have to take that one difference into account. So what if I just directly give this? See, it says list index out of range. The reason is that length of L is 9. So L of 9 indicates it is the 10th element. The index is at 9, so it indicates the 10th element. However, we have only 9 elements, so it goes beyond the range, hence we get the list index out of range. So to accommodate that particular one difference, since it is starting at 0, include a -1. So if you run it, we get the last element, right? Now we need the last 5 elements. So if this is just index, so if I use slice, I get a list. Now if I subtract 1 from here, which means you are asking it to start at this particular position, that is, you are asking it to start at 8. Similarly, if you move over 2 positions, you start from the this all goes in the reverse direction, right? So if you move 2 positions, so you move 2 from this particular position, then to access this element, you move at 3 positions, and then to access this element, you actually move 4 positions. So to extract the last n elements, you need to move n-1 positions from the last index. So this will give you the generic representation. So you can further simplify this. So -1 -4 is -5. So if you want to extract the last n elements, you can do it using this notation, that is length of list minus n. So this is to extract last n elements. So the notation is list, and in that, first pick the last element, and to accommodate for the one difference, you subtract 1 and minus n-1. So if you simplify it, it finally gives you list of n. So I am able to do it directly because of practice, but since you are starting out, you can just do it step by step. So you just need to frame the logic or how you solve it, or devise the approach to solve a problem mentally. Then you just execute those steps one by one into your code. That is how you solve any problem. So this is one way to get the output. You can also use another method, which I believe I showed in the quiz in string slicing. So L just -5. So this will give you everything, right? So what it indicates is L of 5 will start at the first, start at the 5th index. So if you use -5, as I said, minus reverses the direction. So when I give -5, it will pick from the last 5. That is what it tells you is start from the 5th element from the last. That is what this representation means. So you can use this also. Let's have a look at the various operations and methods that can be done on lists. Once again, I am telling you, lists are highly important and play a very important role in Python programming. So you must remember all these functions very well. Do not by heart them, just know what they do, and if you forget it, you can always use your documentation by going to the help function, and once you keep using them through lots of practice, they are automatically registered in your mind and you can naturally use them for solving your tasks thereafter. So here are two sample lists to perform all the operations. The first is L1, which has 5 elements 1, 2, 3, 4, 5, and the second is L2, which has 6 elements, where the first 3 are integers 1, 2, 3. In the fourth element is a list itself, where that list contains 3 elements inside it, and then we have a string and another number. Okay, so I'll just use these two to demonstrate all the other functions that we are going to see now. So first is the list length, which you are already familiar with. So length of the collection will give you how many elements are present. So for a string it will give how many characters are present, and for a list it will just show you how many elements are present inside. So this is your L2. So length of L2 is 6, because this is 1, 2, 3, and this itself is 4, 5 and 6. Now if you take L2 of 3, what will be the output? So in L2 is 0, 1, 2 and 3. So this is your L2 of 3. So it gives you that particular list. Now again, this in turn is a collection, so you can apply length to it again. So that will give you 3, because this particular collection has 3 elements inside. So when it goes to indexing, slicing or your list functions, you can apply your functions as long as they are collection. The same with the string. So all these functions and operations can be applied over your collections until they are out of the collection format. Next, we have what we call as nested list, that is list inside list. So this L3 is going to be your nested list. So basically what L3 looks like is something like this. See, we have list notation, which is square brackets, and inside this is the first element, right? So this is your first element, and then this is your second element, and this is again your third element. So if it is difficult with if it is confusing with all these brackets and commas combined together, you can always visualize it in this way. Okay, so this basically is a list containing 3 elements, where each of the element contains 3 items themselves. So it is like you can imagine like rows and columns, 3 cross 3 rows and columns, or 3 cross 3 matrix. So you can visualize it and interpret it that way. So this is your L3. But if you run your length, if you find the length of L3, what is going to be the output? It is only going to be 3, because as far as L3 is concerned, it has only these 3 items or these 3 elements. So the length is going to be 3. Now L3 of 0 is this, L3 of 1 is this item, and L3 of 2, because this is 0th index, first index and second index. If we print the values, you can see the corresponding outputs. So L3 of 0 is 1, 2, 3, L3 of 1 is this, and L3 of 2. So now for each of these, again they are separate collections, right? So you can apply your length separately for them, so which gives you 3 as the output. And remember, length of an empty list is always 0, because there are no elements present inside it. Now let us move on to the other operations. So next is concatenation. Again, this is something you are already familiar with. So adding a plus sign will combine 2 lists. So L1 plus L2 will give you the combined list. So this was L1 and this was L2. So when you concatenate both, they are combined and merged into a single list. Or you can even, instead of adding list with list, you can just add individual elements to a list. Even that is applicable. So if I just run this, you have L1 plus A and B alone get added to this particular list. So this is concatenation, and repetition is multiplying the list by n number of times. So I am using 2 here. So L1 is multiplied twice. This is repetition. Then we have membership. So in and not in operators. 7 in L1. Is 7 present in L1? For our reference, let me print L1 here. So this is L1. So 7 in L1. Is 7 present in L1? No. So the answer is going to be false. Then 3 in L1, it is going to be true. Similarly, just like in, we have not in. So 7 not in L1 is going to give you true because 7 is not present in L1. So concatenation, repetition and membership, these are quite easy to understand and remember. Now we will look at all, just like how we had certain methods for strings. Now let us look at the methods that are available under list. So if you look at the bottom, so these are the methods available in list. So we have about 11 methods, right? 11, right? 5, yeah, there are 11 methods and you need to remember each one of them. They are very essential. So I'll be going through one by one and demonstrating with examples how they are used and how to apply them. So once again, let me just print out my L1. So this is the L1, which contains 5 elements, 1, 2, 3, 4 and 5. So list.append of x, it adds an element x to list. So whatever value you specify here gets added to your list. So in L1, if I use L1.append a, so a gets added to L1. This is how you add elements to your lists. Next we have list.clear. It deletes all the elements from the list. So first print L2. So this is the value of L2. Then I am giving L2.clear, which will delete all the elements from L2. So after deletion, if you print your L2 again, you can see it is an empty list. Next we have okay, I'll explain this concept later separately. Okay, next function we deal with is list.count. So it counts the number of occurrences of x in list. So if this is your list, list.count 10. So it will check whether 10 is present and how many occurrences are present in this particular list. Here we don't have any instance of 10 in these elements, so your output is 0. Now if I give it as 4, you can see 1, 2, so there are 2 cases of 4 present in this list, so your output is going to be 2. So list.count of x will check how many occurrences of x is present in this list. So as you can see, these are all pretty direct and easy to remember, right? You have append, which adds an element to list. Clear deletes an element from list, deletes all the elements from the list. Then you have list.count, which counts the number of elements, number of occurrences of x. Next we have list.extend. So it expands x and adds it to a list. So here you see first print lt and then list.extend abc and print lt. So if I run it, what you can see is this was the value of lt at the initial stage. Then we gave dot extend abc. So these abc got added. So what is the difference here is that you give an iterable over here. So what I mean by iterable is that it should be a collection or an object that you can traverse through or go through index by index. So that is what is meant by iterable. So you are able to access it individually by index and you are able to travel through it. That is what is meant by iterable. So an extend accepts an iterable as an input to this method. What it does is it expands or chooses each character and adds it to the list. So that is what list.extend does. It expands the iterable and adds those individual elements to your list. Now check here, I have lt.extend hello. So this is our lt right now because we modified it in the previous step. So lt, this is your lt, and as I said, this is an iterable, that is you can access elements individually, right, index by index and travel through them. So a string is basically it is a type of iterable. So what happens is it expanded each of these characters, expands each of the values at index and adds them separately to the list. So this is how extend works. Then we have list.index. So it finds the index of the first occurrence of x in list and raises error if x is not found. So this is the value of LT. I'm checking for LT.index of 4. So it checks for the index of first occurrence. So where is 4 present from the start? It is 0, 1, 2 and 3. It is present at the third index. This is the first occurrence. So it gives 3 as the output. And what if that particular value is not in this index? So it raises an error. It says value error, high is not in list. And again you can see you have your optional values, optional inputs, that is your start and end. So if you specify your start and end, it will search within that particular range. Otherwise it will check through the entire list, because the default value for start is 0 and default value for end is until the end of the list. Next we have list.insert. So it inserts a value before index in list. So we give two inputs to this function insert. One is the index where you want to insert your element and the value of the element. So what inserts does is it inserts value before the index in list. So here we have LT. This is our list with 5 elements. So index starts from 0 and ends at 4. Then you insert 2, 10. So this is the index before which you want to insert your value, that is your 10. So if I run it, this is my initial list. Now I am inserting 10 at the second index. So 0, 1 and 2. At the second index 10 is inserted. So this is your list.insert. Next we have list.pop. What it does is it removes and returns the item at index. So when you mention the index, it will remove the element at that particular index and return it back. If index is not specified, pop the last element. So if you don't specify any particular index over here, by default it will delete the last element and return what was deleted, or raise error if the list is empty or index is out of range. So look here, this is the value of LT. Then I am popping at the second index. So what element was at the second index, that gets removed and returned. Since it is returning something, you have to receive it with something. So I am using a variable to accept that value. So the 10 is stored in X. So if you print LT, you can see that 10 has been popped. We call the terminology as popping. So 10 has been popped and that value is returned in X. So if you print X, you can see the output is 10. So this is the output for the first print statement. This is output for the second print statement, and this is the output for the third print statement. Now here we have specified an index. What if we leave out the index? As the definition says, if index is not specified, pop the last element. So by default, your last element, which was 8, was popped. Okay. So you can see lt.pop, whatever was popped is stored in X. So after popping, the value is removed from the list, and which value was removed is stored in X, which is this particular element 8. Now if list is empty or if index is out of range. So if you look at LT right now, we have 4 elements, which means the indexing is from 0 to 3. Now if I give lt.pop 8, which means I am asking this particular program to pop the pop the element at the 8th index, which is not possible because we have only from 0 to 3. So this will generate an error. So it says pop index out of range. Next we have list.remove. So it removes the first occurrence of value in list and raises error if value is not present. So in your list, if you give list.remove a particular value, it will check whether that value is present in the list and delete it delete the first occurrence of that particular value. If you run it, you can see I have given lt.remove 7. So it will check for the first occurrence of 7, which is at this position, and remove it from the list. And it will raise an error if that particular value is not present. Here we don't have 12 in the list, so if I give 12.remove, it says X is not in list. So unlike string functions, you can see that list functions are quite easy and really direct. So you shouldn't have any difficulties in learning what they are. And since we have only about 11 functions, they are also easy to remember. And as I said, you don't have to by heart the exact syntax and more stuff. So with more practice, you will get used to, whenever you think you see a problem, you will know like what function to use at which particular moment. So that comes with practice. Next we have list.reverse, which will reverse a list. So it changes the list itself. So this was our LT. Now I'm giving lt.reverse. So LT is reversed. So the modification is done on the list itself. So here from now on, anywhere where you use LT, this will be your LT, not this. Next we have, just like reverse, we have sort. And also, as you can see, all these function names are pretty much, they do the exact same thing as your English meanings. So you have extend, count will count, clear will delete, append means addition in English, so append will add, and extend is you are extending or you are expanding it. Then insert will insert element, pop will delete element, remove is going to remove element again. And the difference between pop and remove is that in pop you specify which index you want to remove. In remove you specify the value that you want to remove. Okay, this is the difference between pop and remove. They both delete elements from list, but in pop you mention the index where you want to remove the element, and in remove you directly mention which value you want to remove. And also, if you don't specify anything, it will by default pop the last element, but here it will just throw an error saying the item or element is not found. Next we saw reverse, which reverses. Then sort will sort the string, sort the list. So it sorts a list and changes the list itself. So if this is the list, this is our input list. If you give l.sort, so it automatically sorts, or it arranges them in the ascending order. Now within this sort, if we add this particular parameter or this particular statement or expression, that reverse equal to true, it will sort in the descending order. So if you mention this reverse equal to true, it will sort in descending order. If you don't mention, by default it will sort in the ascending order. Then we have a concept called shallow copy or deep copy. So this is achieved using list.copy function. So see here, first look at the example. We have a list ls with values 1, 2, 3, 4, 5 and 6. So there are 6 values in ls. Then I am copying this, or what you say, I am assigning ls to lq. So what happens if I give a equal to 5 and b equal to a? So the value of a gets assigned to b2, right? So same way I am assigning the value of ls to lq. So this right hand side gets assigned to left hand side. So if you print it, this is your lq. Okay, or let me be even more clear. So we have ls as 1, 2, 3, 4, 5, 6 and lq as 1, 2, 3, 4, 5, 6 because lq equal to ls. Now I am appending hello, appending this hello to lq, right? So we have LQ as 1 2 3 4 5 6 along with hello. So LQ was basically the same as LS. We didn't change anything in LS, right? We only modified and updated value in LQ. LS remains the same. We didn't perform any operation on LS so far. Now if you print the value of LS, what do you think its value will be? Will it be 1 2 3 4 5 6 or will it be the value of LQ? Because note, we defined a value for LS and assigned that value to LQ. After that we didn't use LQ anywhere, we didn't change its value, we didn't update or modify it. We only added this hello to LQ and not LS. Now if I print LS, you can see now this hello is also added to LS. Even though we only added it to LQ, this hello got added to LS too. So this kind of updation is called shallow copying. So what happens is, whenever you equate this particular variable to another, any changes to this variable is also reflected in the original variable. This is called shallow copying. So what happens is, most programmers, they just do shallow copy in their program. They forget, most of them actually don't know that a concept like this exists in Python. So usually they just assign values like how they used to do in integers. As I said before, you use a equal to 5 and b equal to a, then perform operations on b. As long as integers are concerned, that kind of double updation doesn't take place. So whatever you update on b gets updated only on b. But in case of lists, whatever you update on the new variable whose value you got it assigned from another, both values are affected. So this is called shallow copying. So any change you do on LQ gets saved in LS also. So anywhere if you want to use LS again, you won't have the original value of LS that you had intended it to be. You have some new value which got updated at later point in LQ. So to avoid this problem, we have a function called copy. So what this copy does is, it will create a separate copy of LS and equate that particular copy to LQ rather than directly assigning LS to LQ. So this way your original LS remains as it is even if you change LQ. So see here. So I am appending, that is adding value hello. So I am just redefining my LS here because LS got updated here, right? So I am just redeclaring the variable and now using ls.copy and assigning it to LQ. Then printing LQ. So you have LQ as this value. Now I am appending hello to LQ just like before, but instead of directly using just equal to LS, now I am using ls.copy. That is the only difference from the previous case. Now if you check out, the change is only affected in LQ. So the change you do in LQ is reflected only on LQ and LS remains as it is. But in the previous case, the change you did on LQ is reflected even in LS. So when you use just equal to, it does what is called shallow copying, where both variables are affected. But you use dot copy, it is called deep copying, where only the variable that you want to change gets altered. So this is achieved using list.copy function. So far we have seen these 11 functions that are available under these 11 methods that are available in lists. First is append, which adds an element to a list. Next is clear, which deletes all the elements in a list. So copy performs your deep copying. So original value is retained, only the change is reflected in the copied value. And then count counts the number of occurrences. Extend expands your iterable and adds it to your list. Index will give you the index where you have that particular variable, and insert will insert your variable at the position that you give. Pop will remove and return a variable. Remove will pop will do it based on the index, remove will do it based on the value, reverse will reverse the list, and sort will sort the list. So these are the 11 list methods that are available under the list data type. So you have to remember all these 11. So once again, let me tell you, lists are really important. So make sure you are clear with lists before moving on to the next topics. and as I told you before, everything is progressive, so what you learn now is going to be used in the next topic. So you need to be clear with one particular topic then and there. So that is going to help you a lot in understanding and learning Python really fast.
Quiz time, guys. You got a few minutes to think.
Now it's time for a quiz. We have two questions. First is to find out the difference between list.append and list.extend. So if you go over to list.append, so it adds an element x to a given list. So if you give any value, it gets added into a list. Now list.extend also expands list and add it to list. So I'll just show you an example. Say this is our list, L equal to 1, 2, 3. Now if I give L dot append 4, so 4 is added to the list, right? Now since we have changed the value of L, let me run it again so that the value gets resetted. So now the value of L is 1, 2, 3. If I give L dot extend, if you run it, it will show you an error because, as I said, this has to be an iterable. So if I make it to a list and now run it, now it has executed. Now check for the value. Again we have L is 1, 2, 3, 4. So in this case also we had L as 1, 2, 3, 4 after appending, and here we had after extending, but we did change it instead of a number to another collection. So do you think this is the only difference that is between append and extend, or is there any other difference? So you can check out with your help documentation, compare both definitions, compare how many values are passed, what values are passed, what type of values are output, and check what are the differences. Is there any other difference other than this? And the next question, find out the difference between sorted list and list.sort. So now let me modify this. I'll just do it in a fresh copy. So 17307. So this let this be a sample list. Now if I give sorted of L, so it sorts and gives us the list. If I give L dot sort and print it, so now this too gives the same output. So what is the difference between sorted of list and list.sort? You can check out again the documentation for sorted, check out the documentation for .sort, and find out what is the difference between those two.
Time's up. Now evaluate yourself and keep listening.
So let us check out the documentation for append first. Help list.append, and then for the extend method. So check out both definitions. It says append L of append object to none, append object to end. So it will add an object to the end. And here L dot extend to none, extend list by appending elements from the iterable. So these are the definitions. So this none is what it denotes is that it is returning. It is not returning anything. So if it returns something, it will show you what type of value it is returning. Here it is not returning something, it is just adding particular value. So returning something is your program giving you some sort of output in return for your input. But here we are not having anything like that. We are just giving it a value and it adds it to the list, right? So only when you print your list you get the output. Otherwise it is just added and kept as it is in memory. Whereas in pop we saw that it returns some value, so we had to store it and use the variable, right? So this is what this representation means, that is L dot append accepts an object and does not return anything, and what it does is it appends this particular object to the end. Same way L dot extend accepts an iterable as its input, does not return anything as output, and what it does is it extends list by appending elements from the iterable. So as you can see, the only difference is this object and iterable, which is exactly what I explained it now in the question. So okay, see here. So you have a list dot extend xyz. It extends separately. It extends the contents and then adds them separately. L dot append directly adds your entire value as its argument. So if I run it, the first case it expanded and then added one by one. The last case, append directly added this without expanding. So this is the key difference between extend and append. In extend you can give multiple values and all those values are added individually, but in append you can only add one particular element at a time. So if you give a list, it will take this entire list as one element and add it to the list. If you give something like instead of giving a single element, if I give something like if I give multiple elements, say I'm giving 3 particular elements to add, it will generate an error. See, append takes exactly one argument. So these particular values that we pass over to methods, they are called arguments. So we will look at arguments in detail when we deal with functions. There are many types of arguments and many ways in which you can define an argument. So we can go through all that when we deal with functions. So for now, just know the terminology. This input that we give to a method or function is called the argument. So you can see it says append takes exactly one argument, but 3 are given. So this is the difference between append and extend. So extend separates the contents of argument and adds to list. Append always takes only one element as argument. Next, we have sorted list and list.sort. Again, so let this be the list. What happens in list.sort is that it is sorted so the list is sorted and it is directly sorted on the list itself. So it sorts the list and changes the list itself, that is it updates the original list. But in sorted, now if I give sorted L, so it sorts the list, however the original list remains the same. What it does is it creates a copy and sorts that copy, then returns that copy. That is what sorted does. Whereas L.sort directly rearranges the elements in the original list itself. So that is the difference between L.sort, using dot sort and sorted method. So if you want, you can check out the documentation again. Help list.sort. This means you are asking the documentation to look for the sort method under lists. And then we have help of sorted. So as you can see here, we used list.sort, right? So it is available under list, whereas sorted we just directly used it. So it is not a function that is explicitly available in list, so it can be used for other types also. It is a generic function, just like length. Even in length we didn't use like list.length or string.length, we just used length of that collection. So it is a generic function that is available, that can be used for any collections. Similarly, sorted also can be used for other types. So now help of sorted. As you can see the definitions, L.sort, key is none, reverse is false. So as I said, giving reverse equal to true or false will decide whether it is in alternate ascending or descending order. And then we have sorted, where it returns a new list containing all items from the iterable in ascending order. So here the change done directly on the list. Here it returns a new list, that is, it creates a copy, changes that copy and gives us the result.